For our project, we decided to analyze the bounce heights for different balls using the coefficient of restitution. My name is Mahima Dataguru.
My name is Hayden Farrell.
My name's Charlie Green.
My name's Henry.
My name's Rachel.
My name is Kylie Stinson.
This is our table of contents. And as background, when a ball is dropped, the gravitational potential energy is converted into kinetic energy. And when the ball hits a surface, some of that energy is lost, causing the ball to bounce at a lower height than when it was dropped. And for our project, we decided to compare the bounce height based on ball type, surface type, and drop height. So the basic principles that we used for our project was the formula for the coefficient of restitution. And as you can see, the coefficient of restitution is based on the velocities of the objects before and after impact. But since our second object, the surface, is stationary, we simplified the equation so that it's just the square root of the drop height over the bounce height. And our main objective was to determine how the bounce height varies with drop height, ball type, and surface type.
Next, we'll go into a little bit of our experimental design. So to expand about what we said earlier, we're going to have three factors with the initial height of 3 levels, low, medium, and high, the ball used, 2 levels with the ping pong ball and golf ball, and the bounce surface, which is 3 levels, which is concrete, wood, and metal. We had 5 replicates of each factor combination, so that had a total of 90 trials, which we completed. Next slide, please. This is our cause and effect diagram, a bit self-explanatory. As you can see, all the different factors go into have bounce height. Next slide. So this will be expanded upon a little later, but the balls are dropped from an adjustable servo, which we hope will reduce error.
So our main hypotheses are for our ball surface and height, and they kind of follow the same format where our null is where the mean coefficient of restitution for that factor is going to be the same. And the alternative is that the mean coefficient of restitution for at least one of the factors is going to be different. And if you go to the next slide, it shows our interaction hypotheses would follow a similar format where the different factors are either independent for the null or dependent for the alternate.
All right, for our process, we decided to make a mechanism to help reduce error and deliver consistent results for our project. So the first step was we clamped the servo onto a certain height. It was either high, medium, or low. The ranges are on the slide, and we would drop the ball with a repeated number of trials. So we did 5 trials at each height, and we did each height for each ball we were testing. And this process helped us to minimize error and keep consistent results. We recorded the process of the ball being dropped each time, and we slowed it down so we could see what height the ball bounced to. This is a picture of our setup. We had the servo, we had inch measurements, so it was like a yardstick, and we had our Arduino connected to the laptop and servo, which is how we controlled our mechanism. This is a video of our mechanism.
Moving forward into our data analysis, for our overall data, we have here the mean and standard deviation for the ping pong ball. The important factor here is that the mean generally falls around the 0.8 to 0.85 range with a relatively consistent standard deviation. But if we move forward to the golf ball data, we can see that there is an outlier group for the metal case where it is much lower compared to the ping pong ball group and the cement and wood group for the golf ball. And the standard deviation also changes a little bit for the metal compared to the rest of the data. And if we move forward to the overall mean and standard deviation, we can see that this does impact the overall calculations for the ping pong ball versus the golf ball, where the golf ball is lower and has a much higher standard deviation compared to the ping pong ball. And moving on, we have our box plots.
In the box plots, it kind of shows the range of data as explained with the mean and standard deviation. As seen in each box plot visually, the metal is significantly lower for both balls, and that's because, as talked about before, the ball may absorb some vibrations. So moving forward, our best tool of analysis was decided to be the three-way ANOVA analysis. This is because we have three factors, each factor tested equally with interaction pairs and an interaction between all three, being ball surface and height. Following through with the calculations of sum of squares, mean squares, and the F critical value, we can see the necessary p-values to compare with our significance level alpha being 5% or 0.5, with the only null hypothesis being rejected for the ball, which will be further explained in the conclusion.
As Kelly was saying, in the ANOVA table, we saw that the coefficient of restitution depends solely on the ball type, which was the only one with a p-value of less than 0.05. And we found that the bounce depended on the surfaces. The wood cement produced the highest mean bounces, with metal surfaces performing badly for both types of balls. And the metal surface could be a potential source of error, because we statistically found that the coefficient of restitution depended solely on the ball. So maybe, there's vibration or something throughout the metal surface. Throughout the experiment, it showed that the ping pong ball showed more consistent behavior, and the golf ball showed higher levels of variability. Some room for improvement. We can improve the measurement accuracy with the high FPS camera. We could test on more surfaces or increase the amount of trials per surface. And then maybe compute some confidence intervals for differences in the mean bounce ratios. And then the results clearly showed that the surface material highly affected bounce behavior, and that there's a high amount of variability with the golf balls, whereas the ping pong balls were mostly consistent. Any questions?